Stronger than double bond is more stronger than single bond. Reactivity, reactivity. Double bonds are more reactive than triple bonds are more reactive than single bond. Because of the presence of pi electron, because of the presence of pi electrons, double bond and triple bond are more reactive, are more reactive. Double bond is more reactive than triple bond because triple bond is more electronegative, more electronegative. Hence, electrons are tightly packed. Hence, electrons are tightly packed. Copy it fast. Done. Done. What type of bond is formed between px and py in y-axis? No bond. Two different p orbital never forms bond. Which of the following forms sigma bond on z-axis? 2s 2s, 2pz 2pz, spz, px px. Won't this be correct, Rebecca? Won't this be correct, Rebecca? Pooja, Pratyusha. S and S always form sigma bond on any axis. आप ऐसा तो ऐसे लेके आओगे, then also they will form sigma bond. ऐसे लेके आओगे, then also they will form sigma bond. You will take them in z axis, also they will form sigma bond. So A is correct, B is correct, C is correct. Your concepts are not clear. Be sure about your answer. Options तो मैं कुछ भी देता हूँ. Komal is saying this is correct. Rebecca is saying this is correct. No one is saying this correct. Komal is also correct. Rebecca is also correct, but no one said about SNS. So sigma, 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 pi. Any doubt in this? Khushi, Pratyusha. अंडरस्टूड. तो अब हमें कंसेप्ट क्लियर रखो, क्वेश्चन कैसे भी आ सकता है. अगर मैं यहाँ पे ऑल ऑफ दीज लिख देता, then you must have thought about others also, but I didn't write all of these. ठीक है, अगर ऐसा क्वेश्चन आता तो डेफिनेटली you will get all of these as the answer because multiple correct are not there in medical. Okay. Write on valence bond treatment. For molecules. Okay. What do you mean by covalency? What do we mean by covalency? What do you mean by covalency? Maximum number of bonds that can be formed by an element. Deepika, maximum number of bonds that can be formed by an element. Okay. Let's talk about beryllium. We know only valence electron will participate in bonding. Beryllium is 1s2, 2s2. Beryllium is 1s2, 2s2. So this is 2s. This is 2p. Ground state. If this electron excites here, this is its excited state. How many covalent bonds it can form? How many covalent bonds it can form? How many covalent bonds it can form? How many coordinate bonds it can form? Obviously in excited state. Always. How many coordinate bonds it can form? And in coordinate bond it will act as acceptor. In coordinate bond it will act as acceptor. तो कोवेलेंसी कितनी हो गई? कोवेलेंसी हो गई 4. अंडरस्टूड? अंडरस्टूड? Any doubt to anyone in all the three properties? Please go through it again, let me know. So in BeCl2, first excited state of beryllium fluorine will take its electron. There will be a 2s3p overlap. 2s3p overlap. And sp hybridization. Any doubt till here? Two s3p and 2p3 and 2p3. Fluorine has its unpaired electron in which subshell? Pratyusha. Fluorine has its unpaired electron in which subshell? Pratyusha. Which p? Pratyusha. कौन सा p? 3p. इसीलिए मैंने लिखा है 2s3p and 2p3p overlap. Chemical bonding is a very important chapter. Question can come from anywhere. Understood? Any doubt in this? Beryllium? All of you? देख लो starting से. Done?
Sir,
Yes.
so I
Yes,
had a
yes, yes.
question regarding this thing only. So for
Yes, yes.
BCl2, now for chlorine 1,3s will overlap with 3p. Sorry, 1,3p will overlap with 2s and 3p will overlap with 2p. Is it like that?
Yeah, this, what is this? This is 2s 3p overlap. 2s of beryllium, 3p of chlorine. And
But
this
chlorine
is,
has only one over there, no?
so we will be having two, no?
Um,
There will be two
I see.
chlorine, no? BCl2 has,
Okay, yeah, there are
BCl2 has
two
two chlorine,
chlorine.
right?
Yeah. Okay. Yeah, then it's SP and P and P. Okay.
Understood?
Yeah. Thank you.
All of you understood this now? Boron. Boron is 2s2 2p1. How many maximum covalent bond? Maximum covalent bond? 3. Covalency? Covalency? 4. Covalency 4. 3 covalent, 1 coordinate. Komal, there is only one vacant orbital, so it can form only one coordinate bond. And can act as acceptor. Understood? All of you? So in BCl3, there will be boron, two P, 2s and 2p. Chlorine will come. Chlorine will come and forms 2s 3p, 3p 3p, 3p 3p overlap. Understood. Understood. All of you. Done. Can you write down all these things for CH4, carbon? What is covalency? How many sigma bonds? Hybridization and everything. Which overlap? Can you write these things for carbon and CH4? Rebecca 2p3. Okay, Pratyusha, Rebecca. वो बाय मिस्टेक लिख दिया है. It is 2p3. Carbon. How many covalent bonds? How many covalent bonds? 4. How many coordinate bonds? Coordinate bond. 0. Hybridization. Hybridization. sp3. First excited state. Overlap. 1s2s, 1s2p, 1s2p, 1s2p. Komal, any doubt? Okay, we'll do this again. Carbon is 2s2, 2p2. Any doubt? This was the ground state. First, we have to write it like this. Okay, Komal. Now we want to form 4 bonds, but we have only 2 unpaired electron. तो ये इलेक्ट्रॉन यहां चला जाएगा, first excited state. Now for coordinate bond, either you need the lone pair electrons or you need the vacant orbital. There is no lone pair, no vacant orbital. So coordinate 0, covalent 4. Okay, Komal. Now this is carbon. नयनी, this is carbon. ये पूरा कार्बन है. This is carbon. Now what is hydrogen? Hydrogen is 1s1. So 4 hydrogen are coming. 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen. Hydrogen has electron in 1s. Carbon has electron in 2s. So this will be 1s 2s overlap. Okay, Nayani. This will be 2p 1s overlap. 3 times. 1s because of hydrogen, 2p because of carbon. Okay, Nayani. Understood? ठीक है. Covalency is 4. Definitely, Asmita. All of you understood? Can we move to PCl5? PCl5. Phosphorus is 3s2 3p3. Now we want to form 5 bonds. But we have only 3 unpaired electron. So 1 electron will excite to here. First excited state. Now it can form 5 bonds. It will be a 3s 3p 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 3D, 3p overlap. Overlap. Any doubt, clear? Phosphorus can maximum form 6 bonds. As it has vacant d orbitals as well. Understood? Any doubt in this? 9 bonds बनाना बहुत difficult होता है. For any element, the most suitable is 6. Otherwise, 9 atoms cannot be accommodated by a single atom. बहुत unstable structure बन जाएगा, टूट जाएगा. 6 is the most appropriate shape. इसलिए maximum elements want to attain 6 only. It is not solely depending upon the number of vacant d orbital. It also depends upon the stability. Okay, Deepika, Pratyusha. ठीक है, 9 एटम अपने पास रखना बहुत डिफिकल्ट होता है. Understood, all of you? Any doubt till here? Any doubt till here? All of you understand? So in that orbital, how it sits. Yeah, here a vacant orbital can come. Sorry, a donor atom can come, and a coordinate bond can be formed. If you know the coordination compound chapter, then ligands come like this only. They look for the vacant orbital and they just put their electrons in those vacant orbitals, and hence they form the coordinate bond. If you know the coordination compound chapter, Pratyusha, this is what we do there. We just look for the vacant orbital and we just put there the electrons donated by ligands to those atoms. That's it. Okay, Pratyusha. Deepika understood. Can you tell me all this information for SF6 and IF7? कौन सा excited state लगेगा? Which hybridization will come? Which excited state? Which hybridization? Can you tell me all those things? Done? Which excited state? Which excited state? Sulfur is 3s to 3p4. No, Komal. Ground state. Only two unpaired electron. So one electron will get excited. First excited state, four unpaired electron. Second excited state, one more electron get excited. So second excited state we have Komal. Three S, 3P, 3D. So 3S, 2P, 3P, 2P, 3D, 2P. Very good, Pratyusha. Covalency 6. Done all of you? IF7. So it has formed 6 bonds, right? So its covalency is 6. Five S2, 5P5. Try this by your own. Third excited state. sp3d3. Covalency 7. It is 5S, 2P, 5P, 2P, 5D, 2P. Very good, Pratyusha. Any problem where you are in this? Understood, all of you? Tell me about this. Komal sp3d3, 7 orbitals are required. You are saying only 6. sp3d कैसे हो सकता है यार दीपिका? वी हैव ओनली 3 बॉन्ड्स, तो हाइब्रिडाइजेशन में भी वही आएगा ना, एक लोन पेयर है तो sp3 आना चाहिए. Nitrogen is 2s2 2p3. Ground state. 3 hydrogens. 1 hydrogen, 2 hydrogen, 3 hydrogen. Covalency 4. Covalency 4. 3 covalent, 1 coordinate. 3 covalent, 1 coordinate. Hybridization sp3. 2s1s, 2p1s, 3 times. Any doubt in this? sp3d कैसे हुआ? नाइट्रोजन के अंदर डी ऑर्बिटल होता ही नहीं है दीपिका. नाइट्रोजन is a second period element, do not have d orbital. Nitrogen is a second period element. 2d does not exist. 2d does not exist. तो नाइट्रोजन के पास 2d होता ही नहीं है. What happens to the lone pair means it will be used in forming a coordinate bond. It will be used in the formation of coordinate bond. In a coordinate bond, it will act as donor atom. Ramchandra, it can maximum form 4 bonds, 1 coordinate, 3 covalent. So that means N will never form. Okay, Ramchandra, understood. Three covalent bond, one coordinate bond, hence four bonds. Covalence is four. In that coordinate bond, nitrogen will act as donor. Any other doubt? So that means nitrogen will never form compounds with higher atoms. Not more than four. Even not more than three you can say. क्योंकि फोर्थ वाला भी कोऑर्डिनेट बॉन्ड बनाएगा. थ्री कोवेलेंट वन कोऑर्डिनेट. Now try for water. Water. Oxygen is 2s2 2p4. 2s 2p. Now these electrons cannot be excited. So this will remain as lone pair. Two lone pair. That means two coordinate bond if at all required. जिसमें वो एक्ट करेगा एज डोनर. Two covalent bond. क्यों? Because of two unpaired electron. इसलिए कोवैलेंसी हो गई 4. कोवैलेंसी हो गई 4. हाइब्रिडाइजेशन sp3. Hybridization sp3. So 2p 1s 2 bonds. Understood? Understood? HCl 3s2 3p5. Ground state. Hydrogen is 1s1. So there will be only one bond. 3s 1p. Sorry, 3p 1s overlapping. Understood. Three lone pair, one bond pair. If at all required, it can form three coordinate bond. Okay. Any doubt in this? Second period elements have covalency. Yes, Pratyusha, sp3 hybridization. Has covalency 4 because absence of vacant D. Other elements can form bonds up to 6 generally. Hence, covalency is 6. Presence of vacant D. Presence of vacant D. Understood? All of you? If we talk about N2, so in N2, nitrogen is 2s2 2p3, and we know N2 is like this. We have to form three bonds. So first bond will be a sigma bond. Other bonds will be pi bond. First bond between two atoms is sigma bond. Upcoming bonds pi bonds. First sigma, second pi. So this will be the sigma bond. This will be the pi bond. This will be the pi bond. Understood? So N2 has p pi multiple bonding. Understood? 2p and 2p are forming pi bond. So it is called 2p pi multiple bonding. There will definitely be a S also, but I am talking about this as of now. There is 2p pi multiple bonding. There is 2p sigma bond. They will be the lone pairs. Lone pairs. Okay, Asmita. All of you understood 2p pi multiple bonding. For O2, SO2, SO3. Which multiple bonding do we have? Which multiple bonding, Komal? Two p pi multiple bonding. Why not sigma means 2p, 2p, sigma is also there. Three p pi, 2p pi, 3d pi, 3d pi, 2p pi, multiple bonding. Any doubt in this? All of you, Komal, Deepika, Asmita, Siddhi, Ramchandra, Gauri, any problem to anyone? Suhas, all of you, any problem to anyone? Then tell me for this. See, in SO2, we have to form four bonds. We have to form four bonds. 3s2, 3p4. And one lone pair is there. 3d is also there, that is vacant initial. Now we want to form four bonds. तो ये एक्साइट करेंगे. First excited state. Four bonds. First bond will be sigma, second bond will be sigma, third bond will be pi, fourth bond will be pi. Second side we have oxygen, which is 2s2, 2p4. That means it has its unpaired electron in 2p only. So this will be 2p, 3p, 2p, 3p, 2p, 3p, 2p, 3d. These are pi bonds. These are sigma bonds. And this is lone pair. Now tell me for SO3. Which pi bonds? How many pi bonds? The second bond of P should be pi bonds. Why? First we form both sigma bonds, then we form both pi bonds. पहले दोनों सिग्मा बनेंगे फिर पाई बनेंगे. It won't be like sigma pi sigma pi. So here there will be 3p pi, 2p pi, 3d pi, 2p pi, 3d pi, 2p pi, multiple bonds. Three p, 2p, sigma bonds. 3s, 2p, sigma bonds. Understood? Can I say second period element can never have p pi or d pi multiple bond. Can we say this? Yes or no? Can we make this statement? सेकेंड पीरियड एलिमेंट से अगर मॉलिक्यूल है तो उसमें डी पाई का बॉन्ड नहीं हो सकता. देयर कैन ओनली बी पी पाई मल्टीपल बॉन्ड. Which among the following has p pi d pi multiple bond? Which among the following has p pi d pi multiple bond? Understood? Third Pira element. Any doubt in this? PCl5 exists, but NCl5 do not. Why? N cannot have more than cannot have more than four bonds. Does not have vacant D. Understood? All of you understood this? Hybridization. What do you mean by hybridization? It is the mixing of atomic orbitals of similar energy to generate new orbitals, new orbitals to generate new orbitals called hybrid orbitals having equal energy, shape, and equidistant from each other. equidistant from each other. Understood? Number of orbitals combining is equal to the number of new hybrid orbitals formed always. Hybridization includes sigma bond, lone pair, negative charge, not pi bond. Okay, like when 2s and 2p combines, they give two new orbitals named sp. When 2s and 2p like this combines, this all we have done just now, they will generate new orbitals. Its name will be sp2, sp2, sp2. Bond angle we know 180 degree, bond angle we know 120 degree. Similarly, if 2s and 2p like this combines, it gives sp3, 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 sp3. Understood? 109.5 degree. Nitrogen, there's 5 on. Nitrogen hybridization is not sp3 for all the compounds. It is for ammonia. ओके प्रत्युषा, देखो आप लोगों ने 11 12 दोनों कर रखी है ना, तो इफ आई टेक द नेम ऑफ पिरिडीन, तो आप वो भी समझ सकते हो. इन पिरिडीन हाउ मेनी सिग्मा बॉन्ड्स आर देयर? प्रत्युषा, नाइट्रोजन के पास कितने सिग्मा बॉन्ड है? One sigma bond, two sigma bond, and there is a lone pair. तो 1 2 3, तो हाइब्रिडाइजेशन यहाँ पर है sp2. ओके, azide One sigma bond,
So,
one sigma bond. Yes, yes.
so no, I was saying like for N2, like now in that previous example, you had given it like 2p, right? Like two separate 2p orbitals, and you had given like one sigma and two pi bonds, like this. And
Yes.
yet the hybridization is sp3.
No, I didn't say that hybridization is sp3. Did I say it? Show me.
Uh,
I don't think. Why will I say
but
sp3?
then
No,
it
we didn't
won't
say
be
sp3 is
sp3.
there. Why? sp3 hybridization depends upon the number of lone pair and the sigma bonds you have.
Hmm.
sp3 is only for ammonia. I gave you two new examples. If you see pyridine, then hybridization
Yeah.
is sp2.
Hmm.
If you see this azide ion, it is sp.
Oh, okay.
Okay. So it
Yeah.
depends upon the molecule. If I give you pyrrole
Hmm.
or I give you this furan, okay, let's take this as of now. So this has three sigma bonds, one lone pair, so it is sp3.
Yeah.
Okay, depends upon number of
Hmm.
sigma and pi bond.
Okay.
It's not fixed. Okay, yeah.
Hmm. So that's why that's meant no pi bond is involved in any of this
No, pi
mentioned.
bond won't be involved. Yeah.
Oh, okay. Thank you.
Understood, all of you? So hybrid orbital is shown like this. For sp, there are two hybrid orbitals shown like this. So this is sp. ये सब NCERT का है, so it is important. sp2, three orbitals. One, two, three. sp3, four orbitals. One, two, three, four. Understood? Understood. So rest back bonding and bridge bonding we'll do in next class. अभी इतना करते हैं. Rest we'll do in next class. Bridge bonding, back bonding we'll do in this chapter only. Okay, so please do not miss the next class. It's bridge bonding and back bonding. ठीक है, मिस नहीं करना. Back bonding, bridge bonding are very much important.